Welcome back to Nemesis Giant. We're going to take a look at 2008 here with stereo H1A. Our object is going to be coming into view here in a few seconds. See the sun start emitting CMEs here. Here comes a loop, big plasma loop coming off. And then over here on the left, we've got our object coming into view. Still got a large plasma loop coming from what would probably be one of the brown dwarf stars. Now it seems to be orbiting a lot slower this year rather than last year. What it's doing to the surface of this here dwarf. Not having that much effect on this, but it's just lighting this little bugger up. It's taken us 4 months to go past this time, whereas last year in 2007 it went by in 2 months. Now this is on its orbit in on 1A. It's going to go past, turn around and come back. We've got another, this might be one of our other dwarfs here. Supposedly the planets won't have any kind of reaction to it. Of course, nothing's proven here. Everything's kind of speculation. Still can't say that this thing exists, but there's a whole lot of evidence that's proven otherwise. They're doing a good job of hiding it, as it's pretty much disappeared there, but it's still going past and the sun's still reacting to it violently. We're going to get our loop. Plasma loop's going to come off of here and follow it in just a few seconds. Once it gets far enough away that it starts pulling away from it. Got another object entering the screen here that's creating an ejection. Now here comes our plasma loop. And it's ejecting. And see, it's kind of on an angle up here, which is where our object came across up on above the sun, where it would be pointing down this way, facing straight towards the sun, if that's what it was actually pulling from. Let's jump on over to 1B. Now, we've got an ejection coming out here, and we're going to have a huge loop coming out. Now, they've done a real good job of hiding it here in B. see the sun's reacting violently right now. But you don't see anything. And we've got our loop. The object's actually just about into frame now. They've just got it hidden good enough. It's going to appear here in a few seconds. It's already going to be out almost mid-frame by the time they can't cover it anymore. We should see it any second now. It's going to be out around this way here. Now remember, it was going very slow. And here it is. Here's the very bottom edge of it. Can't see any of it up here. They still got that all covered. Somehow they've got it masked out very good. But you can see it here, and it's coming more into view. Now we can see almost this full edge. And it'll become more visible here shortly. As we're passing it here with this dwarf, I would imagine, of course it's lit up like a tree. Christmas tree, that is. And we can see it a whole lot better now. As it starts to pull away from the sun's going to start reacting extremely violently this year. In 2008, it still had quite a bit of strength left in it. There we go. That mass ejection. I don't even know what you would call these. I don't know if they're flares or they're CMEs. It's just the whole sun just basically exploding. Of course, there are CMEs coming off of it. But what do you call it when the whole damn sun just gets 10 times its own size like that? Yeah, I mean, take a look at these. It's just crazy. Now you see our loop here. And that other object that went through. It's kind of hidden in the sun's mass there. Now we'll get another one. Here we go. This one's coming out now. See, it's coming back here to our giant. It's not going to our sun. Now, if that thing was a lens flare, or a camera anomaly, or a whatever, then these other planets wouldn't, or these other suns or stars or whatever they are, they wouldn't be having any kind of reaction to it. We're coming out of April, we're going into May, now the sun's just going to go insane. We'll follow it through May, and there's good reason for that. I'll explain explain that here in a second. Got a very violent sun here in May. Say it's pretty pissed off about something. Doesn't just do that for no reason. Okay. Let's stop this for a second and take a look at our earthquakes this year. Had a total of 9. These are just the major ones here. We've got 2 grouped in May, a 7-9 and a 5-9. Then we got a big swarm in October. And this is why I wanted to follow us into May. Got the 12th and the 24th. Go back here, we're in the 27th. Now what I also wanted to say, we've been talking that it takes 72 hours or so for a CME or a flare to hit the Earth. Well, saying here, got different forms of radiation, all have unique characteristics. They all share one, which is their speed. Since these particles all travel at the speed of light, 300,000 kilometers per second, solar flare energy takes about 500 seconds to arrive at Earth, a little more than 8 minutes after it leaves the sun. Here, while CMEs are pretty rare, but there are almost always smaller amounts of energy particles that come from a solar flare. The speed of these particles depends on the strength and rapidity of the flare that sends them flying. The highest energy particles from the flare can arrive in as little as 2 minutes after electromagnetic radiation, while CMEs take up to 3 to 4 days. Okay, so CMEs can take 3 to 4 days, but these flares can take anywhere from, we got as little as 2 minutes, 8 minutes. So what do we call those huge explosions? Are we calling them CMEs? Are we calling them flares? What are we calling them? But if they can hit within 2 minutes, then we don't need to look back 3 days or 4 days, although we can. Now what do we have? Got May 12th and the 24th. There, we just stopped on the 27th. There's the 8th. So anywhere around the 9th to the up to the 12th. There's some pretty violent reactions in there. Got 3 days, 3 to 4 days, up to 8 minutes. There's 3 days out. Now, I mean, are we calling this a flare? Are we calling this a CME? I'd call it just an explosion. If that's not pushing particles, I don't know what is. But they're talking about strength, and dependent upon the strength and rapidity is how fast it reaches Earth. These are pretty damn strong, and as far as rapidity, it's pretty much constant. All the way up to the 12th. and then the other one was out on the 24th. And we'll start on the 19th. There we go. 20th we had a huge explosion, and then it pretty much stays pretty rapid. Pretty high on the strength chart here. As far as rapidity goes, it's just constant up through the 24th. So there's an easy cause for your two big earthquakes there. And then, of course, through October, we get the 5th, 6th, 11th, and 29th, so we can just pretty much say the whole month was spaced out. We don't need to look at every day. October. We had our object here. It seems like H1 doesn't really show too many of the real bad explosions on there. H2 always shows, or H1B always shows it much better. I didn't even look at that as we were following it. Let's take a look and see what happens on B. See if it shows it coming past from the other side. Now, yeah, there we go. Now our object's not going to be here because it's on the other side, but the reaction of the sun we're going to see. There we go. Look at that. Now, if that's not causing our earthquakes, I know you say our object's not here, but the object's actually orbiting on the other side. It's behind our satellite here. Mass CME. But just the sheer violent reaction of the sun. And just to throw one other thing in there, we actually had a volcano eruption that month, the Chitan volcano. Erupted from May the 2nd through November. Of course, we've already checked out everything that happened in May and all of our other activity in October. And this thing erupted from May through November. So, just curiosity. Okay, that's my video for the day for 2008. Hope you enjoyed this one. Be making another one. We do 2009 next. Y'all have a good day. Remember, subscribe to my channel. See you next time.